engineering. These are my colleagues, Samita and Namya, and myself, Vishika.
Traditional software engineering often rushes straight into code writing, assuming we fully understand what client wants. Design thinking, flipping that approach upside down. It is a human-centered, iterative methodology that ensures we build right product before we focus on the product right. In software, design thinking bridges the gap between technical requirements and human experience, helping dev teams avoid building feature-rich systems that nobody actually wants to use. The first stage of design thinking is empathize. In software engineering, empathizing means looking past raw specs and ticket descriptions to understand the real human beings who will use our application. We conduct user interviews, shadow workflows, and analyzing existing user pain points. As engineers, we often fixate on system metrics like latency or throughput, but empathizing forces us to ask, is this interface confusing? Where does our user feel frustrated? Understanding user friction early saves hundreds of hours of refracting later in the development lifecycle.
Once we understand our users, we move into the second stage of design thinking, define. Here we aggregate all the qualitative feedbacks, crash reports, and user feature points collected during the empathize stage research and compress them into a single clear problem statement. In software development, the stage stops us from working on big requirements like make and check out faster. Instead, we format into an actionable how might we find statements such as how might we reduce checkout drops of the mobiles user on low bandwidth networks. This gives us an entire engineering team on a clear target on aligned towards. With tight problem defined we enter the third stage, ideate. This is the where engineers UI designing and product management brainstorm potential solution with technical bias. In traditional development, we tend to pick the first system, architecture or framework of the paths and aheads. Ideation challenges to generate dozens of broad ideas ranging from UI designing shortcuts and background processing of first architect. By holding off on immediate techniques critiques, we give space for creative technical approach that we might have otherwise missed.
Picking the most promising ideas, we move to the fourth stage, prototype. In standard software delivery, prototype is often confused with building a full minimum viable product. In design thinking, however, prototyping is about building the fastest and lowest cost representation of an idea to test a specific hypothesis. In software engineering, prototyping exists on a visual and architectural spectrum. It can change from low fidelity wireframes sketched on papers or interactive Figma mocks to high fidelity technical proofs of concept. For instance, if our solution involves a complex API integration or a new algorithmic workflows, an engineer might write a lightweight, hard-coded script to verify performance before designing the full production database schema. The goal here isn't clear. Production-ready code is fast feedback that proves whether an architectural or user experience concept actually holds up.
The final stage of the process is test. We put our low fidelity wireframes or technical POCs directly in front of end users and stakeholders to gather actionable feedback. In software engineering, testing isn't just about passing unit tests or automated integration suites. It's about usability testing. We observe how real people navigate the interface, where this gets stuck, and whether the solution is actually resolves the problem defined in stage 2. What makes design thinking so powerful for developers is that it is non-linear and highly iterative. If usability test reveals that users are confused by our onboarding workflow, we don't declare failure. Instead, we cycle back to the ideation or definition stage, armed with actual data. By combining design thinking with agile development sprints, engineering teams build products that are not only architecturally sound and scalable, but genuinely loved by the people using them. Thank you.